Today's lesson, we're going to talk about zero or polynomial functions. Zero or polynomial functions, we're going to briefly going over remainder theorems, factor theorems, and rationalized zero theorems. Probably all these theorems or definition we should be able to understand better when we're looking at the example. So I'm going to come back with that definitions while we're doing our examples. So example 1, it say find the remainder of these functions when you're dividing with the given, right? So they want you to find the remainder when you're dividing with these numbers. So you should be able to use the long divisions, but synthetic division is the easier way of doing it. So I'm going to use the synthetic division to see if I can divide. When you're using synthetic divisions, you need to make sure you write descending order. And if you have any missing terms, you're going to replace by 0, right? Same thing with the long divisions. So this is going to be what we're going to divide with x minus 3. So I'm going to play with this one first by descending order. And synthetic divisions, we drop the variable. We only use the coefficients. So from x cubed, I'm going to use 1. X squared, I'm going to use negative 4. X is the missing terms, right? Start from cube, square, and x to the first is missing, so we're going to use 0. Constants will be negative 5. So let me write that. So I'm going to have 1, negative 4, 0, and negative 5. We're dividing this with x minus 3. So it will be positive 3 is what we're going to divide with. So synthetic divisions, you're going to bring down the first number straight down. So that's going to be 1. And with this number, you're going to multiply by 3 and right under negative 4. So you're going to multiply this 2 number and write it here. Once you have this 2 number, you're going to add them, right? So 3 times 1 will be 3. And when you're adding this 2 number, it will be negative 1. And you're repeating that procedure. So you're going to do 3 times negative 1. That's going to be negative 3. And add this 2 number, it will be negative 3. And now you have another numbers to multiply. So it will be 3 times negative 3 will be negative 9. And add this 2 number will give you negative 14. So when you're dividing this f of x function with x minus 3, this is going to be what you're going to have remains. So because you divide cubic function with linear, what's left over is going to be quadratic. So third power divided by first power, so you're going to end up getting x squared. So this first term start with x squared. So it will be 1x squared minus 1x minus 3. And this is going to be your remainder. So let me write that down, what you're going to have. So you're going to end up getting 1x squared minus 1x minus 3 with remainder of negative 14. So that's what you're going to get when you're dividing f of x function with x minus 3. So that's what you're going to get. Or if you wanted to use the remainder theorem, right? The remainder theorem right here. If you wanted to use the remainder theorems, then if you, so let me do or, if you do f of 3, then you're going to get negative 14. So let's try that. So then on the x cubed, all the x going to be replaced by 3. So it will be 3 cubed, let me write it, 3 cubed minus 4 times 3 squared minus 5. This should be giving you negative 14. That's what remainder theorem is, right? So it said when f of x is divided by x minus c, your remainder is going to be same as when you're replacing c into the functions. So c into the functions and get your remainder. So this remainder will be the same. So you should be able to use the synthetic divisions to find out your remainder, or you can just replace and see if you're going to get remainder. Either remainder should be the same thing. And if you end up getting 0 for the remainder, that means this x minus 3 is going to be a factor of this polynomial function. So that's going to be one solution. That's what factor theorem means, right? But again, we didn't get 0 here. So x minus 3 is not going to be factor of f of x functions. Let's try the next one. So this one, we're going to try, make sure we know how to use synthetic divisions and understand the remainder theorems, right? That's what we're trying to do here. So again, we're dividing this polynomial function x plus this polynomial function with x plus 2. So let me write the coefficient from that polynomial functions. That will be 1, negative 4, 0, negative 5. Dividing with this time x plus 2, so it will be negative 2. You always just bring down, bring straight down the first number. So that's going to be 1. And now you have numbers to multiply. So you're going to do negative 2 times 1 will be negative 2. And you're going to add these two numbers, so that will be negative 6. And again, now you have two numbers to multiply and write it on underneath the 0. That's going to be positive 12. 0 plus 12 will be 12. And now negative 2 times 12, that will be negative 24. Add those two numbers will be negative 29. So your remainder is negative 29. So this means if you did f of negative 2, so replace all the x with negative 2, f of x functions, that's 3. Minus 5, you will get negative 29. So that's what remainder theorem means. When you replace x plus 2, this x plus 2, negative 2, into the functions, your remainder will be same as when you're replacing the 2 into the function, negative 2 into the functions, right? And for the factor theorems, because this is not going to be 0, this is not 0, x plus 2 is not a factor of f of x. Now then, example 2 is asking to use the factor theorems to determine whether the function has the factor. So they wanted to know if this is factor of this functions or this is factor of that functions. So in order to be a factor of this given functions, your remainder have to be 0, right? That was the factor theorem's definitions. So what we're going to do, we're going to use the synthetic divisions. So if we do 2, so I'm looking at the given functions, right? Only copy down the coefficients by descending order, and if you have a missing term, use a 0. It looked like I don't have any missing terms. Started with cube, square, first, and constant, right? Just write down the coefficients. -1, 2, and -3, dividing with x minus 1, right? X minus 1 means you're going to divide with positive 1. Bring down the first number, multiply that 2, added 1 times 1, 2 plus 1, 1 times 3, -3 plus 3 is 0. Because your remainder is 0. Because your remainder is 0, x minus 1 is a factor of the given functions. And if you didn't want to use the synthetic divisions, you could also do f of 1 and replace it into the f of x functions. And when you figure this one out, this is going to be 2 minus 1 plus 2 minus 3. That gives you 0, right? That's another way of seeing if the x minus 1 is factor of f of x. And that's what, let me go back to definition, that's what factor theorems means, right? So then x minus c is a factor of f of x if and only if when fc is equals to 0. That's what it means right here. Okay, so I'm going to try one more time and see. This time, without using the synthetic division, I should be able to just replace x with -2, right? So I will do -2, and then I do 2 times -2 cubed minus -2 squared plus 2 times -2 minus 3. So basically, I just replace my -2 into f of x functions, right? All the x got replaced with -2. And let's see if I get 0. So that's going to be 2 times -8 minus positive 4 minus 4 minus 3. This is all the negative numbers. So if this is all negative number, I don't think I will get 0, right? So let's make sure I get 16. That's going to be -8, -3. That gives you -16 minus 11. So it looks like this is going to be -27. My notes, I use the synthetic divisions. So you can tell you get the same remainder using the synthetic division or replacing x with the value. And because your remainder is not 0, x plus 2 is not a factor. Is what we can find out using the factor theorems. The next example, example 3, is ask us to find the list of all possible rational zeros. It does not mean it's going to be a factor. Rational zero means this 0. right? The value, it will give you your remainder 0. That means that number is going to be factor of the solutions. So when it say list all possible rational 0 means list all the possible solutions, right? Or possible factor, because factor become a solutions. If this is factor, your solution, well, this is factor. If this is the factor, your solution is going to be positive 1, right? So how do we do that? Well, that we're going to use rational zero theorems. So remember, rational zero theorems will give you the possibility of the solutions comes from factor of constant over factor of the leading coefficients. So that's what we're going to use. So if we wanted to find all the possibilities, again, it's not going to be all the solution or factor, but possible solution come from this set of the groups. This one, your constant is going to be positive for leading coefficients. I guess I have x missing. Let me write that down. So that it will be constant is going to be positive 4, leading coefficient is going to be negative 4. So the numerator is factor of 4, denominator will be factor of negative 4. So factor of 4 and negative 4, that's going to be plus minus. So I like to use plus minus in front of it because all this number can be either positive or negative. Factor of positive 4 can be 1, 2, and 4. Factor of negative 4, I'm not using the sign because my sign will be here. So factor of 4 is going to be again 1, 2, and 4. And we need to use mix and match. So when denominator is 1, it will be 1, 2, 4, right? It will be 1. So plus minus 1, plus minus 2, plus minus 4. When denominator is 2, it will be 1 over 2. 2 over 2 is going to be 1, right? So you don't need to repeat the same number. 4 over 2 is going to be 2. So only plus minus 1 over 2 remains. That's another one that you need to write, right? And then when denominator is 4, it will be 1 over 4. 2 over 4 is 1 over 2. 4 over 4 is going to be 1. So you only need to add 1 over 4. So this is the possibilities. So if you cannot factor and no factor was given, then this is how you're going to find the possibility. So you're going to have these one solutions from here. So one solution of this functions should be here. So after this, you're going to try to see, plug into all this. So how many? 1, 2, 3, 4, 5. So 10 of it. You're going to replace it for x and see which one gives you 0. And that number is going to be a factor, right? That's how you're going to reduce 4th power into the 3rd. So once you find one solution, you have 3 more to go, right? Okay, so let's look at the next one. So right now, our exercise is to see if we can find the possible rational 0, possible solutions, right? So that's going to be factor of constant, which is negative 6, over factor of leading coefficients. this time, because denominator is 1, it will be all whole number, right? Last choice. Again, it will be plus minus, right? And factor of 6 is 1, 2, 3, and 6. So you have 4. Because you have plus minus signs, you have 8 numbers to try to see which one will be the solution of your given functions. And we will do that. We will do that in next examples. Right now, just to see if we can find the possible rational zeros. So we need to make sure our final solution should be plus minus 1, plus minus 2, plus minus 3, and plus minus 6, right? Out of this 8 number, at least one solution should be there. Right? What about this one? The third one, you have constants, positive 10, leading coefficient negative 2. So factor of, so it will start with plus minus, and factor of 10 is 1, 2, 5, and 10. Factor of 2 is 1 and 2. So if you pick and match, let me do all the whole number with denominator 1 first. Will be plus minus 1, plus minus 2, plus minus 5, plus minus 10. Now with the 2 on denominator will be plus minus 1 half. 2 over 2 is 1. I already have that. 5 over 2. And 10 over 2. 10 over 2 is 5, right? And I already have that. So this one have more options or more numbers that you need to try. 1, 2, 3, 4, 5, 6 plus minus. So will be 12 values that you can try. And one of that 12 should be the solution of that f of x functions. So now we're going to do real problems. Find the zero. Find the zero means find the solutions. The number that will give you remainder 0, right? So again, you have several ways of doing it. But first step will be finding a possible 0. And then the second step will be testing. When you're testing, you can use the synthetic division or replace it here to see which one gives you 0, right? It's up to you. My notes, I use synthetic divisions. So maybe 1 or 2 problems from here, I will use the replacing the numbers, so you will see the difference. Way of doing it, but you're going to end up getting the same answer. Okay, so let's see. The step number 1 will be always find the possible 0, so you have a numbers to test, right? Find possible 0. Your leading coefficient, which is denominator being 1, your option will be smaller, factor of negative 6. So it will be 1, 2, 3, and 6. And there's little tricks that you can use to see, instead of trying all 8 numbers, or you don't know if you're going to start with positive or negative number. The little trick that I use, if your sign is same, one after the other one is same. So the first term is positive, second term is positive, and then you have negative, negative together. So the same signs together like that. Usually I like to use the negative numbers first, right? Or this one, when your sign is rotated, one is positive, one is negative, right? then I like to try the positive number first. So this one, I'm going to try the negative number first. This one, I'm going to try the positive number. What about if this one? I have positive, positive, negative, negative, right? So I will probably try the negative number first on that one. So that's, that's way that you can reduce your choice or a number that you can try into the half. So let's do -1 maybe, right? Let's do -1 because the sign was together. And let me try with synthetic divisions on this one, right? So synthetic divisions, we'll need to write the whole constants and divide by -1. 1 times -1, that's going to be 2 minus 1 will be 1. -1 times 1, -5 minus 1 is -6. -1 times -6 is +6. That's 0. So this means that x plus 1 is the factor, or -1 is the solutions. So we find that one. So what happened when we find that one solution? It starts with cube, right? So now this is going to be quadratic. If you want to, you can repeat this procedure to find next two solutions. But we already know once you reduce to quadratic, we know how to find the solution of any types of quadratic. So maybe we can do that. So that's going to be x squared plus x minus 6 is what left over. So basically when you're factoring x plus 1 from given f of x functions, this is what you have remain, and you should be able to factor this, which that's going to be plus 3 and x minus 2. So your solution is going to be not just -1, you have -3 and +2. And that's how you can find all the zeros of given polynomial function. So finding a solutions. So your solution of that function is going to be -3, -1, +2. And this is your factor, right? This 3 is the factor of this polynomial functions. And I maybe will show you, I will get the same answer if I replace -1 here, right? So let's try that too. So then -1 will give you -1 cube plus 2 times -1 square minus 5 times -1 minus 6, right? That will give you -1. And then -1 square is +1 plus 2, times 2 is plus 2. And this gives you +5 and minus 6. So it looks like you have 7 negative and 7 positive, which will give you 0, right? So either plug into the x or using a synthetic divisions, you will get 0 for the remainder, 0 for the remainder. So you know x plus 1 is the factor, means x -1 is the solutions. And then reduce to cubic equation into quadratic, because what's left over will be the quadratic, and then find the rest of the solutions. Let's do one more with this. So your possible 0 is, again, leading coefficient being 1. Just the factor of the constant. So it will be plus minus 1, plus minus 2. This is cubic function again, cubic. So if we can find just one solution, we should be reduced to quadratic and then be able to find the rest of the solutions, 2 more solutions. So probably I like to use the synthetic divisions, because if I use the synthetic divisions, I will find my quadratic equation. What's the leftover equations, right? Leftover equations, then I'd be able to factor or use any method of solving quadratic to find the rest of the solutions. So again, I'm going to use the synthetic divisions. So it will be 1 from the cube, third power, negative 4 from the square, 3 from the x, and constant is 2. Dividing this with, remember I'm going to use a positive number, right? So if I do 1, let's see what happened. It will be 1, negative 3 will be 0, will be 0, 2. So that didn't work, right? So now I'm going to try, remember I'm going to use positive number first, right? Because the sign was rotate. 1 was positive and this is negative, right? So then if I use 2, it will be 1 times 2, that will be negative 2, times 2 is negative 4, that will be negative 1, negative 2, 0. So this is one of the solutions. So x minus 2 is one of the factor. Once you factor x minus 2, what's left over? 1x squared minus 2x minus 1, right? And that's quadratic equation. So this is not a factorable, because 1 times 1 cannot be, no matter what number, a factor of 1 is just 1. And you cannot make negative 2 when the sign is going to be different, right? So it's not factorable. So if it's not factorable, you can use either quadratic formula or completing the square method. And if I use quadratic formulas, I will do negative b plus minus square root of b squared minus 4ac all over 2a. So don't forget that formula, right? Again, let me write the formula of quadratic equations. Your solution is minus b plus minus square root of b squared minus 4ac all over 2a, right? I'm using that formula here. And when you simplify this, it will be 2 plus minus square root of 4, because you have subtracting negative, will be plus 4 all over 2 is 2 plus minus square root of 8 over 2. This is going to give you 2 plus minus 2 square root of 2 over 2. And you should be able to reduce that. Gives you 1 plus minus square root of 2. So you do have 2 more solutions right here. One with the positive one with the negative one. And remember, you had another one there before. So your solution x is 2 and 1 minus square root of 2 and 1 plus square root of 2. So 3 solutions for cubic equations. I'm going to try one last one on this video because the one that we were looking at both cube, right? So once we find one solution, we were able to find the other two from the quadratic equation, either factoring or use the quadratic formula. This is the fourth. So fourth will be reduced at first to the third, right, cubic. And then we need to do one more procedure, going through the same thing over again, and then reduce to quadratic and then find. So you need to repeat two of this, right? So that's what I wanted to show you. It will be the same thing, it's just that you need to reduce all the way to quadratic. It means from the fourth powers to the quadratic means two more of these steps. Two more steps, right? So let's do some finding a possible zero. Possible zero, your leading coefficient is 2. So you need to have one with the whole number and one with the denominator being 2, right? So one with the whole number, I will have plus minus 1, which is going to be a factor of 6. 2, 3, 6, and then you have plus minus 6 over 2 is 3. Well, let's do 1 over 2, 1 over 2, and 2 over 2 is 1, 3 over 2, and 6 over 2 is 3, right? So that's the options. You have 1, 2, 3, 4, 5, 6, 12 of it. But because we know that little cheat sheet that I was talking about, repeating the same sign, right? Positive, positive, negative, negative together. So we're going to use the negative value first. And I usually like to start with this simpler number, right? The fraction is the harder one. So let's try -1 first. So then synthetic divisions, copy all the coefficients. 2, 5, -2, -11, -6. I'm going to divide this with -1. Then it will be 2 times -1. 5 minus 2. -1 times 3. That's -5. Positive 5, -6. Positive 6 will be 0. So at this point, my cubic equations, because I end up factoring x plus 1 out, right? My cubic is going to be 2x cubed plus 3x squared minus 5x minus 6. And then we're going to do one more synthetic divisions to get quadratic. And my possible zero is going to be a constant, factor of constant over factor of leading coefficients, which is same as the first one, right? I had -6 and 2. So possibility is going to be the same. And this one, your sign is also together. Positive, positive, negative, negative. So I'm going to use -1 again instead of +1 first, right? This is going to be 2, bring down -1 times 2. That will be +1 times -1. That's -6 times -1 is +6, which is 0. So now you had another factor, x plus 1. You have quadratic now. It will be 2x squared plus 1 minus x minus 6. And this quadratic look like it's factorable. When I factor, I get 2x minus 3, x plus 2. So this is the factor. So 4 factor for my fourth power functions, right? Right here. So it means my solutions is going to be -1, -1, and you have 3/2 and -2, right? So this one you get 3/2, this one you get -2. So when you write this down, you don't need to write same solutions twice, but you do know you have 2 of -1. So when you're graphing it, it will act different than when you have one of the solutions. -2 and 3/2. And maybe you can notice for yourself you have 2 of these solutions.